now we're going to get into one of those assessment technologies. And the reason I talk about this is because I'm Sales and Marketing Director for Tektronix. I say that up front so you know where I'm coming from, you know my bias, you know what I'm doing. But I'm also, you need to know me a little bit better. I'm going to tell you the truth. I'm not going to tear down a competitor or somebody I don't like. If I'm better than them, I'm going to show you that I'm better. If they're worse than me, I'm not going to talk about it. Because if I can't show you who I am by who I am, I don't need to tear anybody else down. I do that in business. I do that with religion. I do that with thermography. I do that in chiropractic, okay? So I'm just going to give you the basis of what we do, why we do it, how we do it, the physiology behind it, so that if you choose to use thermography as one of your assessment tools in that toolbox we talked about, you understand why it's useful, okay? What we do as chiropractors, we already talked about this. Is it there? Where is it? What is it? And then what do we do to get rid of it? Or help the body get rid of it is more technically correct. Because we don't do anything except for introduce an external, universal, concussive, destructive force. But with our education, experience, and exposure, that vector we introduce should be 100% of what the body's going to use, no more, and no less, to have the body affect the correction. Make sense? Anything left over becomes destructive in the body. Anything less doesn't get the job done. So my goal, even as big as I am, as strong as I am, as quick as I am, is to deliver 101% in case one of us flinches. That's why I'm the gentle giant. All right, so that's actually was coined quite a while ago. So again, MLPI, I'm not going to go through this. We did talk about this extensively, but I also told you Dr. Kent wrote a piece in 96, 99, where all of the theories out there fit into these four categories. And here it is, 1996, Models of VS, a review. Common to all concepts of subluxation are some form of kinesiologic dysfunction and some form of neurologic involvement. There you go. All right, anatomy, physiology. We have the spinal cord, the dorsal horn, the nerve roots, the chain ganglia, the capillary beds. The function of capillary beds, they have two functions. If they're internal, it's to transfer nutrients in and waste out, right? If they're superficial, it's also to transfer heat from internal to inside to out. Make sense? Capillary beds don't absorb heat. They only get rid of heat. They only dump it. If the caliber of the vessel gets larger, there's more blood, there's more fluid, and therefore the heat dissipation is greater. If it gets smaller or constricted, the blood flow is less, the volume is less, and therefore the heat dissipation is less. Common physiology, right? Even for our first quarter life students, you got this?
I got it.
Makes sense, right? And if we want to have a garden hose talk about capillary beds, we can do that too. All right, so this is from Dynamic Chiropractic in 1994. This work, they're talking about something I'm going to show you extensively that was done by none other than the Canadian Memorial Chiropractic College in the 60s. Even then, they weren't the most philosophical, straight chiropractic college in the world. But even then, they understood how the physiology works in the autonomic nervous system of the paraspinal area, okay? This has all been very well documented in all of neuroanatomy, not just chiropractic neuroanatomy, but all of neuroanatomy. It's a well-known fact and study. And you guys can have the slides. You don't have to take pictures. Okay. Because the pictures include me. And
I was just taking pictures.
You look really good up in that shirt, man.
I usually wear it with some white linen. I thought that would be just a little. You like the shoes too? Which one? Styling and profile. So continuing on the article, this chiropractic thermography enables a doctor to evaluate the autonomic neurophysiology, which is critical to the health of us humans. Evidence confirms what chiropractic says in 1895. So that's pretty cool, right? That that publication said that in 1994. They won't say that today, but that's what they said then. So the thermography is an economical instrument, enables doctors to best track down BS, knowing when they've been corrected. Okay, this is 1994, people. I graduated in 92. So, well, this is the pamphlet. We've been given full written permission to use this in presentations and education. Again, in the 60s by Canadian Memorial, talks about the physiology of all these things and how the dorsal root ganglion and all the preganglion and postganglion fibers control the capillary beds right by the spine. The interesting thing about the capillary beds on either side of the spine is it's completely about heat emission. The other cool thing about this, oh, I love that. Convincing evidence. Thermography could provide objective evidence. It's absolutely positive that it might. Just saying. And that was written, that was the Journal of JCCA. Okay, the Journal of Canadian Chiropractic Association, or something like that. Anyway. Here is a chiropractic journal you might subscribe to, Journal of Neurosurgery, 1988. Says the values of thermography can be used as a standard in assessment of sympathetic nerve function. Boom, there you go. Outside validation and symmetry, and a quantifiable indicator of dysfunction. This is what that rubric started with. Can you believe this? MR X-ray shows M&O. There you go. Got it? So, anyone by themselves, probably not as reliable as a good toolbox. Okay? If you had only one tool in your toolbox, stick with your techniques. All right. A little bit of history of thermography. 1915 was when the first X-ray unit was installed in Iowa, and it was installed in Davenport at a place called Palmer School of Chiropractic in their clinic. So, the very first X-ray unit installed in all of Iowa was there. It was probably one of the first dozen or so installed in a clinic in the United States. Up to that point, it was all research. 10 years later, 1924-25 is when the patent for thermography was filed by Doss Evans and B.J. Palmer. So right in that same time frame, they're taking these technologies of how can we assess what's going on and doing them. So this is not something new. This is as old as and as useful as X-rays. And then Clay Thompson wrote a letter. Does anybody here have any personal connection to Clay Thompson? Dr. Zog back there, baby? How you related to him?
Grandpa.
This is Clay Thompson's granddaughter. Okay, yeah. All hail. All right, so again, this is just a history of basically telling you what I just told you. Dr. Clay Thompson said, the chiropractor, he's writing this letter to say, listen, thermography is not something chiropractic came up with. We're just using it like every other doctor, every other mama uses testing temperature for. It doesn't give us any information other than there might be inflammation going on. There might be an imbalance going on. Chiropractor, on the other hand, makes readings along the spine and then gives an adjustment. We'll reread the spine to see whether or not there has been a response in the temperature changes. Through years of experience, we realized that as temperatures become more equalized throughout the spine, the patient's health has improved. Here's Clay Thompson writing this letter. It's obvious in the medical field that taking the temperature has little to do with the type of disease that's going on. Likewise, it makes little difference chiropractically as what the patient has symptomatically. The response of temperature change guides what we do. Okay? This is early on, 40s, 50s. And here's, this is the first patent for Doss Evans. It's a wacky thing. The temperature sensors are on the tips. It's probably a little rough, caused some rashes, caused some scrapes. Still worked. And all it did was show which side was hotter. No graphs, no pieces of paper. And I remember some people telling us before they actually had the graphs, some people that were in the clinics, of how they had to track them. And Gonstead still kind of uses the same thing with the grease pencil. When they get a break, they'll go back and over it, and then they'll mark it. And they'll go and find another one to mark it. That comes from these early days before there was graphing techniques, either with paper or electronics. They're also looking for something very, very subtle in their technique. So I'm not downing them, I'm just telling you some history. The other one, this is actually a patent by, I believe that's Canadian Memorial Chiropractic's version of it. Put a big box, and the box is like this tall and about this wide, and they roll that up your spine. And basically did the same thing, a little bit more focused on it. And then this is Canadian Memorial Chiropractic. You actually have two things with two needles. So it kind of shows you what's going on both sides, and that's important. We'll talk about that in just a second. I actually have held one of these. They're kind of cool. And this is some important things, because heat is electromagnetic radiation, right? Anything you can do with X-ray, anything you can do with light, anything you can do with sound, you can do with heat. So we can focus X-rays, we can collimate X-rays, we can put tubes, we can put lenses on light. All that stuff can and is being done with heat, okay? So if you have an open camera sensor and you take a picture with no lens, no collimation, what do you get? Fuzz, right? So what was happening with these sensors is they were getting a lot of fuzz unless they were right up against the skin, okay? But people didn't like to scrape people, so they'd hold it back. And what happened is the further you got away from the skin, the more information you got from everything. And at some point it becomes scattered and it becomes useless. Make sense? So one of the ways to do that is you can put a lens on it. And on top of a lens, if you really want to get specific at something, you put a tube on it. There's an observatory that has a 200-foot shaft that's only about 3 foot in diameter. And at the bottom, they have a telescope, and they can actually see stars with a black background in the middle of the day, because they're only looking straight above them, and none of the scatter from the atmosphere gets in that tube. And if it does, it's deadened in the first 50 feet. So they have 150 feet of a black tube underneath, so they can actually observe stars unless the sun is directly overhead. So the tube collimates, gets us more, and then when you put a lens on it, you get some extremely accurate, pinpoint precision readings with anything, any electromagnetic radiation. All right, so hot versus cold. Big debate, not new, been going on for a long time. BJ and Dee Dee got started with using the back of their hands doing nerve tracing, called hot boxes. Where's the heat? Follow the heat. And that's what they used to nerve trace. And the story goes that one of the researchers came to say, we're getting this thermography thing wrong, because according to the physiology, if there's a nerve system imbalance, it can only be sympathetic, which causes constriction. Parasympathetics don't play any part in the capillaries. So if there's an imbalance, it can only be on the side of constriction, which is the side of cold. And BJ looked at everybody else, is like, well, what do you guys think? They're like, well, that's the physiology. And BJ stood up, it's like, as long as I'm alive, it's heat. And he stormed out of the room. So that's kind of where BJ conflicts clarify, right? It's one of his books. Science, interference causes constriction. Interference in the autonomic nervous system only causes the sympathetic response, which causes constriction. But actually, we're looking for a balance. When we look at thermography, is how is it balanced, not only horizontally, but vertically. Okay? If everything is responding to a sympathetic response, you probably don't have interference. If both sides are responding the same, above and below are responding the same, it's probably not interference. It's probably normal. But if everything else is responding differently than this one part, that one part's probably interfered with. Make sense? Cool. But again, the capillary beds are only influenced by the sympathetics. I already just covered this. Dang, I'm so good. I haven't covered my slides before I get there. All right. So thermography, it's been around for 100 years now. Almost. How much research has been done? Not only in the profession, but outside of the profession, it's solid, absolutely solid. So much so that they even did what's called a gauge repeatability study on thermography, which is a Six Sigma manufacturing test. And they found it's one of the highest reliability study results you can get in that test, which is not a chiropractic test, it's an industry manufacturing test. And so they found that they're extremely reliable, extremely precise, extremely accurate. And then, like I said before, thermography, x-ray, those really well-researched and foundational, solid, robust assessment tools are used to validate and support other research. And thermography is there as well. We're going to run through these. This is by Owens, Hart, D'Onofrio, and some other guys that I can't pronounce because I don't have the right glasses on to read them. Here's the gauge repeatability study. This is by Hart, Malo, Boone, Brown, and Ashton in 2007. Here's a Journal of the Canadian Chiropractic Association in 2015. So this is recent stuff. But what I really want to spend time on today is for you to understand the maths behind thermography. The raw data is the key. The raw data. What is that temperature at that spot? Okay? Everything after that is a calculation. And we're going to talk about fuzzy math in a little bit, but here's the math levels, okay? The first level is, what's the difference between the two? That's some grade school math, plus minus. If left or your right is hotter than your left, by how many? And we're going to show, okay, right's hotter by 2. If both sides are hot by 2, what's the difference? 0. Okay, if one is hot by 1 and the other is cold by 1, what's the difference? 2. Right? So we got to be really careful about these things. But the delta T, the change, the difference between the two, that is the standard graph. You have the raw and you have the delta. That's the standard graph, and that's what you make your doctor's decision on. Looking at the raw, looking at the delta, that's what you can make your doctor decision on. Okay? If you're not given that information, it's going to be difficult to make some decisions. Okay? Now, after that, we have a hybrid delta T. This is kind of another layer of analysis on top of the scan. Take an average of the raw data. You see the deviation from average, and you plot that on the graph too. I'm going to show you that here in just a little bit. Then you get into pattern analysis in thermography. So once you establish that thermography, you match that with whether there's a subluxation or not with the other assessments, you can notice patterns just in thermography, saying every time I see this for you, I know this means that listing for you. But that's over a course of time. And then you have layered pattern analysis, where we've noticed these different things that show up every time, but my other assessments show that it's this. And once that's cleared, that goes back, but there's these other layers of patterns. And so that's an extremely advanced type of pattern analysis. And so I consider that doctorate. Which graph am I leaving out? The bar graph. And that's crayons. And I'll explain why I say that. We do bar graphs. CLA does bar graph. Anybody that does the thermography, we do bar graphs because it's easy to understand by the client. It's easy to understand by the public. It is not, in my opinion, usable in a clinic situation. It's not usable information for you unless you're just using it as an overview with everything else. It's not clinically usable. I'll show you the math behind it a little bit. All right, mushy math. 1 plus 1?
2.
Minus 1 plus 1? Minus 1 plus 0?
Minus 1.
Minus 1. 0 plus a minus 1? Kind of getting where I'm going? Mushy math. What are you doing that for? Oh, here we go. You ready? Super mushy math. What's 0 plus 2? What's minus 1 plus 3? You can say it. What's minus 2 plus 4? 2. What's minus 1,000 plus 1,002? 2. What's plus 52 minus 50? 2. Kind of see where when you rely on a calculated number, you may not see what's actually going on. That's why you need to see the raw data to see what's going on. Okay. In fact, I was told by somebody yesterday, before we had the delta T, when they were just doing it one-sided scans, they would do one-sided scans, draw that on paper, do the other side, draw that on paper, and then overlay those to see where they diverged. It's kind of what's, we really need to see the raw data. Okay? If you just rely on the delta T, you may not be seeing everything you need to see as a doctor. All right, so here's a manufactured, in a spreadsheet, raw data. Okay, can you see some things there that aren't balanced left and right? Right, so here's something that's not balanced left and right. Here's another thing that's not balanced. Another thing that's not balanced. These both go the same way, right? There's an imbalance there, there's a slight imbalance here, right? We put those two together and do what's called, so if you consider these direct temperatures, raw data, we put in the calculated data. This is what we call the delta T, the difference between the two. Okay? So this is cool because it shows same here, right? But this is just a little bump. Why is that so far that way? Because this is a little bump below and that's a little bump above, so jacked it up that way. And this was a big spike that way. Why does it only show a little spike here? And why is that spike so big that way when it seems to be appropriate? And then when you get down here, look, there's no spike at all in the delta T. So if you just looked at this, where would you think the problem would be biggest at? We're automatically drawn to this one, right? But if you look at the raw data, that's not near as important as some of these other ones. That's why you have to have all the data there. Make sense? And again, like I said in the first session, and it's not about you or anybody you know, but as a profession, we tend to be a little bit lazy. As people, we tend to be a little bit lazy. As a culture, we tend to be a little bit lazy. Does that make sense? We need to be the professionals and not be lazy. It doesn't take any longer to look at this than it doesn't look at this. Make sense? Look at the raw data, look at the analysis, look at the layers of math. So here's the left side, and it's deviation from average. Okay? So we take all of these points and average them out, and then plot this versus that average. This is what the graph looks like. It's kind of mimics it, right? But if we take that and put it all on the same side, oh, that's the other side. So we take that graph. Anything to the right is going to be warmer than average, anything to the left is going to be colder than average. If we take that and put it all on the same side, see what we're doing here? So again, this is level 3 math. This is called hybrid delta T. We do that and then get rid of it. So this is the left side. I'll show it to you better in a second. And then there's the right side, same thing. We put those together and now we have something called hybrid delta T. So it gives us another level of looking at balance left and right and up and down. Okay? You okay with that? Did I lose anybody in that? Good. Either you're not admitting it or I did a good job of teaching it. But now we can see, okay, where's imbalance? We can see there's big spikes here, so that helps us. Okay, we see the big spikes on the raw, but the big spikes here, it's balanced. Might be a problem there, might not be. This is about imbalance here, right? Here's some imbalance here. So it gives us an indication of where issues may lie. Then we use our other assessment techniques to say, okay, that didn't show up as a peak at all. on the delta T. But here we look at the hybrid delta T, we can see there's an imbalance here. And even here, there's a little bit of imbalance. Here, vertically, there's an imbalance. Okay?
Do you explain this graph to your patients?
I'm sorry?
Would you explain this graph to your patients?
Yeah, see, if you look on this side, there's this vertical line here. It's just the average of all these numbers. Anything to the left of that's going to be a blue bubble over here. Anything to the right of that line is going to be a red bubble on that side. So what it does is shows me imbalance left and right, up and down. But, oh, yeah, that makes sense. And they do usually get it because it's not this jagged up. There's this nice, bubbles. Okay? And so here we have the hybrid delta T, and here we have the delta T. You see the difference in the layers of information you can get? Again, I'm not trying to make you experts in this, but this is what's come up with, what we've come up with as a profession over the last 100 years, and how we can take this information, this raw data, and actually look at derivations of that data, the different math associated with it, and get some useful information out of it. Since we're using computers, might as well use their power, right? Cool with that? Yeah. Are you okay with that? Good. And this is what a hybrid delta T looks like in the Titronic system. We can color code. Anybody could that took the time to do this. Anybody, even you, could do this. Each one of these colors has to do with this temperature difference from zero. And it's just if it's between 0 and 0.5, make it green. If it's 0.5 to 1, make it red. If it's 1 to 1.5, make it purple. You can assign any color you want to these, but this is what a highly colorized hybrid delta T could look like. Myself, because I'm fairly simple and partly colorblind, I just use red and blue. Everybody knows blue is cold, red is hot. Right? And so that's what I do, because that's how I think, but I also know that's how my clients think. Make sense? Any questions on that? All right. So here's 3 scans. Now, the interesting thing is, when you look at this, and you focus completely here, right here is a big area of concern, right? But when you look at the raw data, there's not a whole bunch of difference off of the normal, right? Again, a huge spike to the left here, but when you look at the raw data, it doesn't seem that. So this does help us, but it can't override the raw data, okay? And this is Dr. Amalo's paper. If we just look at the delta T, we can see some huge changes. If we look at the raw, we can kind of see they stay in the same pattern. They just shifted a little bit. We have to look at everything. Ponderance of evidence, as Dr. Just lost her name. She teaches at Sherman. Preponderance of evidence. Jamie. Browning, thank you. Yeah, preponderance of evidence. And again, here, if you just looked at this, would they be okay? Yeah, but look at this. So you got to look at all of this stuff, and that's the point of this. You've got to look at the raw data, and then you look at the analysis. These are the bar graphs. Useful, yes. Clinical, I highly doubt it by themselves. So this is mushy math part 2. Are you ready? So we already went through that. Now what's 2 plus 2 plus 2 plus 2 plus 2? 10. What's the average of those 5 points? 2. Now if we take a -2 and a +4 and a -10 and a +13 and a +5, the sum of that is 10. You have 5 data points. What's the average? 2. That's what bar graphs do, but they do over 16 data points. Okay? Do you follow me so far? So we take this, the same graph, and put it in a bar graph. I had that in the wrong space. This is what we come up with. Okay, useful, yeah, tracking change over time, grossly useful. Is it clinical? Highly susceptible for that, okay? So again, I'm not saying don't use bar graphs. I'm highly recommending you take a look at how you use them, why you use them, where you use them. If you use them at all. All right, so does thermography give us a listing? Absolutely, positively no. Does it give us a level? And I answered here, maybe. When I first started teaching on this, the research I saw says it goes through the chain ganglia. And if you know about the chain ganglia, it gets information above and below all the way down the spine. And it's all sympathetic information, right? And so all that gets jumbled together and then sent out to the target. But then I talked to somebody, and it's like, well, you missed these things that shows there's also extra ganglionic fibers go directly from the cord to the capillary beds. So we have a mixture of both. And then when you throw the philosophy in there that innate's not going to let this thing screw up, it's going to be level specific. You're going to have a nerve that the brain thinks is C3 that's going to be connected to T5. All that information is going to be programmed. No matter what the channels it goes through, it's going to be pretty specific. And so level, probably, but there's also other information there that's getting into the sympathetic response. Side, heat, cold, which one is it? Right? And if they're equal, is that an imbalance? It is if one's was designed to have a larger caliber and it's supposed to be hotter. So we have to look at these things over time. And presence of vertebral subluxation, probably. That's one good thing that we can know. The physiology, the neuroanatomy, the chain of events between the brain, the spinal cord, and the capillary beds is extremely short. Very few other things get in there. We're talking about HRV in the previous hour. We're talking about the vagus nerve. There's so much information that gets into that vagus nerve to help it do its thing. How can we say it's a specific level or it even is a vertebral subluxation causing that? So this pathway is extremely short. It's extremely specific. It's extremely specified and known. So does it show us a presence of an interference? Yes, probably. But over time, this plus everything else you put together can help you establish pattern so that you can say with certainty, when I scan Sally and I see this bubble, I know exactly what her listing is. Because every time I've seen that bubble over the last 5 years, it's the same exact thing, and that's pattern. That's habitualized pattern that the body falls into. Now, when you get into level 4 and 5 and level 2 and 3, and you talk about adaptive changes, as you clear out subluxation patterns, the next oldest pattern emerges. And once that's cleared out, the next oldest pattern emerges. And so being familiar with those changes takes a lot of time and study. And there's courses that, in fact, you can get your diplomate in thermography. All right, other things, again, we talked about the graph of the maths. And I do use maths, plural, intentionally because it's messy. Cold, hot, hot, cold, cold, cold. And then the bar graph issue, we've talked about that. All right, so concerning pattern, because this is something that everybody associates just with the line graphs. Not just you. It's obviously I created this before I met you and you talked this morning, right?
Right.
Pattern is, we have to understand, innate's job is to adapt continually to your environment. If you're not adapting, you're dying. Okay, you're either adapting or you're headed towards death. So innate's job is to keep the organism alive, so it's always adapting to its environment, constantly changing. Its other job is to take those external destructive forces and convert it to internal constructive forces. If you're not adapting, you're stuck, which is pattern. And again, I am part of the leadership team, sales and marketing director for Titronics. Thermography alone does not determine pattern, period. Leg checks alone do not establish pattern. period. X-rays alone do not establish pattern, period. It's all of this stuff put together, the preponderance of the evidence in front of you showing a pattern over time is what establishes pattern, okay? So don't make me slap you. Any questions? How's that?
It's good.
8 minutes left.
You writing a book?
A couple. I'm actually I'm working on my DPHCS, so on the ACP portion. I'm actually doing that paper on note taking and philosophy because nobody's ever done that before. So eventually I'll work on other stuff. But was this useful? Was this beneficial? Is it applicable?
Yes.
Students, is this something that can help you think about what you're going to be taught and how you're going to deal with it in practice?
Yes.
Good. So see me at the booth, take a card. If you need anything from me, let me know. If you want a copy of the presentation, I can send you a PDF of the slides. I'll probably post the video online on the Tektronix YouTube page. So just let me know what I can do for you. Appreciate it. Make sure you get your stuff signed so you get the credits. And have a good day.
Yeah, he did a great job.